Okay, can you hear me? Yeah. So we start last day of our summer school, and this is the last session. And here we will present the ideas of your projects, and then we will get some feedback, and we will proceed to certificate award and final lunch. Okay, who will do the first?
So, hi everyone. Today we would like to present you our project, Agro Data Bot, from field trial data to agronomist-friendly advice. And here is our team from the left to right, Sergei Tokarev, me, Christina Kosiev, and Anastasia Bukevich. We are also grateful to our mentors, Danilo Polyakov from Camel Company and Vijay Yarab from Brooklyn Health, who guide us with their experience and industry vision. Agronomists face multiple challenges when working with trial and crop data. The first problem is time-consuming data search. Finding trial results, hybrids, or crop protection products takes a lot of time, and agronomists must check many spreadsheets and reports. This slows down their work and leaves less time for field activities. The second problem is difficulty comparing results. So results from different hybrids, years, or regions are not easy to compare, and data may be recorded in different ways. This makes it hard to see which combination of methods works best. The third problem is lack of integration with weather data, because weather has a big effect on crops, and without weather information, it is hard to give accurate recommendations for each year or field. Agronomists may not know the best time to plant or apply treatments. The fourth problem is knowledge gap. Limited skills in digital tools and data analysis means that some agronomists and workers cannot fully use trial information, which may result in less accurate recommendations. The next problem is limited accessibility for field staff. Field workers and agronomists often cannot see trial data while they are in the field. This makes quick decisions difficult. Without easy access to information, mistakes can happen or opportunities can be missed. And the last but not least problem is lack of visualization tools. Without graphs or charts, it is difficult to understand the results. Agronomists have to read numbers manually, which can cause mistakes, and visual tools help to see trends and patterns in yield clearly. This data set is the foundation of our project. It contains more than 5,600 rows of real agricultural field trials. Each record captures not only the crop and the treatments, the fertilizers, chemicals with different application timings, but also detailed information such as rates, manufacturers, and the resulting yields. What makes it even more valuable is that we also have a terminology dictionary. It standardizes agronomic terms, product names, and codes. Thanks to this, our chatbot can understand different ways agronomists phrase their questions and still deliver accurate results. The slide also displays a few charts illustrating the distributions of key variables. So let me present our approach to the problem. An AI-powered agronomy knowledge system that is designed to answer agricultural queries with the help of a large language model. In addition to textual answers, the platform will provide visualizations such as charts and tables to better present the results. We plan to build it using a combination of technologies: the Gemini API for LLM capabilities, LangChain for orchestrating the AI workflows, and Fast API to serve the application efficiently. The choice of the platform is not critical at this stage, as we are currently focused on developing the system itself. But on the right, you can see a prototype of the system. Here, a user asks the Viber chatbot specific agronomy questions and receives precise answers. Below, you can see a snippet of the actual code showing how a query is sent to the Gemini API and how the response is returned. Finally, on the far right, we outline the usage flow. The user submits a query, the system converts it into embeddings, retrieves relevant data, performs analysis, and generates the final output as practical pieces of advice for agronomists. So that's it from us today. Thank you for your attention, and we will be happy to hear your feedback and answer any questions you have.
Probably need to take the microphone. It's not. Oh. It's not. Oh, yeah, it's working. Okay. So, you want, as I understood, you want to use a proprietary, I mean, existing method, existing LLMs. You will not fine tune it, or maybe add something extra, need resources.
Of course, we will fine tune it, yeah.
On data of agro companies.
Yeah, we have a data set and we will work with it.
Mhm. Is it in Ukrainian?
Yeah, the data set in Ukrainian.
And is it possible to use also English-based agro data set about anything? Because it can be more reliable and more rich.
Actually, we had a discussion with Danilo from Kernel, and they want the chatbot to answer the questions based only on their dataset, on their trials, and not some other info from the internet.
Okay. No, normal. Okay, thank you. Then
thank you very much.
Who will be next? If you have any comments from Zoom, you can also raise your hands or just switch on at the end and ask questions. One moment. Oops. How many searches? Information was not the break and please if we fail Zoom they one. Can you present? Yes. You don't need I'm already set up. You just present. Just share your screen. There we go. Yeah, but you need to share your screen. Yeah. Okay, so good morning, ladies and gentlemen. I'm excited to share with you our project called Wild Map Restoration. So my name is Andrei, and here is our team of 6 passionate ML developers with diverse background, ready for the task. Our mentor is Danilo Polyakov for panel, and we are excited to start the project and to go solve the problem. So basically, the problem is as follows. The yield maps, these are the maps not from the satellites. These are maps fully collected from combiners. Combiners have sensors
which during harvest day, as combined goes and harvests, the sensors measure how much yield is collected at the moment, and then, as you see on the pictures, it shows the index of this harvest. And the brighter it is, the more harvest is in that direct region. Well, the darker it is, the less harvest it is. So on the left, you have a fully collected perfect map, but on the right, you can see some white lines, straight lines, dot lines. These are some errors in combined sensors. They may be caused by different factors, for example, GP signal loss, maybe just some operational interruption, doesn't matter. So our main task is to fulfill these lines as it should be, well, based on the harvest information we have from the maps, and make this map collected again. So working this data, we have different data from satellites, the digital evaluation model. It's simply, as you can see on the top right corner, it's an evaluation of the height level. For example, this model, you can see black is some low ground and height is some low ground. So this field has high diversity of approximately 10 meters. And the second map is NDVI index. It's data collected from the satellite and it measures the drop intensity. We have different images from different days and months. For example, this one was took on 30th of the 8th month, and the greener it is, the more harvest. The more harvest is on the field. So as you can see, a straight red line. That means that there is some cause which made the crop well poor at this line. This was also be analyzed. And of course, the yield map I just showed you on the previous slide. So the solution we prepared. The first step would be to synchronize, preprocess all these maps because they are all different. They have different measurements. Two maps are in geographical systems, but the third map is magic system and, for example, extension as well. Yield maps is 4 by 4 meters per pixel, but DEM is only 1 by 1. We have to make to combine it all and make it overfit. The second step would be to analyze dependence of the crop yield on indexes and terrain, basically, as I told, and this will let us in the future predict the map harvest without even the yield map. I think we can manage that. The next one would be model a supervised approach for predicting yield values. We are considering different ways for the realization. Well, one of them would be to make a supervised learning model, which will cut some lines on the fully restored fields and then learn how to fill them. And in that we will validate the predictions using all the information we managed to get. So that's basically it. Thank you. And if you have any questions, we are to answer them.
Okay, I wait and comment. And before working the working somehow. So thank you for your presentation. My question is, one just standard interpolation work. Why do you need all these fancy models, ML models? To interpolate the values you have
on the border of the eastern part, and that's it.
I guess that well, we are thinking that these maps were actually good, but as I understand, the question is maybe we can predict with just the satellite data the crop, the yield, but and we don't need to restore the maps.
Okay, because you started with the feeling missing data, and in the title of the project there is missing. The word missing, so that's why I was confused. Okay, thank you.
Yeah, yeah, not working as it should be. I don't know why, but okay. So you will probably use the neighboring pixels to predict the result, and it's quite wide to just make an average or something.
Yeah, something like that. That's the first thing we thought, and but we will also include the information from EEM, from NDVI. So it's not just simply take an average.
Can you also use the previous years, even if this field was sold with different type of culture? It's still, if there is some irregularities on this kind of missing lines or missing area, then you can actually try to use it. So if there is irregularity there, for example, some low place or maybe, then it would be on previous images. And in previous images, probably this area would be spotted, for example. So you can use previous year images to predict is there any irregularity. It's not if everything is like uniform, then you can just use uniform to cover unknown areas.
Yeah, we have different maps. Some maps cover the same field from different years, and of course they have like different errors on them, and we'll count on that as well. Some maps are unique, and in that way we don't have this opportunity, but basically, yes, we will include this as well.
Okay, any other questions? No, thank you then. Okay. 21, can you go into Zoom before you came into?
Proszę. Głosowanie wypłacamy, no.
Ну, є в календарі, є вже так багато людей.
We thought that we would connect via HDMI or something. Sorry.
Okay, it's only Tuesday, you will learn. I mean, from Tuesday, everyone presented through Zoom, but yeah.
Yeah. So the Google Meet.
No,
Zoom. Okay. Zoom. Okay.
No, just click on it.
No, I can't.
Just click.
I know I can't because like my Chrome won't call it Zoom. Sorry. Only my Chrome is capable of Zoom. My where is it?
Okay, here's one.
Okay. Okay. We'll start. Hello everyone. We and me and Vika, we are developing a solution to this problem. The problem is that there are two diffusion apparatuses that process grain and process food products, And sometimes they get overloaded, which negatively impacts the equipment and the phrase right, it's a problem, and there are special human operators operating these diffuser mechanisms, and they try to monitor this load metric so that it doesn't exceed 300 amperes, right, and doesn't damage the system. And what we are giving is a data set that contains, oh, why did it? Okay, it stopped sharing for some reason. Okay, let's hope this won't stop sharing again. So okay, like tell me if it stops sharing again. So yeah, so the we're given a table with a lot of features and two metrics that are our target metrics, which is the load on the apparatus 1 and load on apparatus 2. And we are asked to predict whether in the next hour, after like an hour passes, after this point in time, one of them will overload, which is very important because if we do predict that one of them will overload, then we can possibly make some recommendations to our operators so that they prevent this overloading, because every time the apparatus overloads, it needs to be sometimes needs to be stopped, sometimes needs to be restarted. It all wastes money. So we want to predict this and give recommendations to the operators. Okay, so we looked at the existing research on this topic, and most of the research is concentrated around nuclear plants, for example, supplying energy to cities. In energy grids, it's really important to predict loads because because you cannot just sometimes you can just stop the nuclear plants right away, and you have to predict the load. And in the preprocessing stage, the existing research says that longer temporal contexts show reduced error in the short-term load forecasting, and that it is common to use timeline features in the inputs to the model. Then the recent approaches show the ensemble tree models, neural architectures used for modeling the loads, and for given recommendations, we usually we do it after we build the model. We use post hoc explainable AI, methods like SHAPICE and PDP. And after we have this explanation, sometimes we also can make a recommendation, and we also emphasize, and the research emphasizes that we have to distinguish between controllable and non-controllable graph drivers in this case. So like the drivers that the operators can actually control, and this is one way. So this is the whole thing we just presented is when there are operators that control the system, and we're giving recommendation to the operators. But there is also an alternative approach, which works like end-to-end, which is called reinforcement learning. So we have an agent, we have an environment, right? We want this agent to prevent overloading in the environments. This is a new topic. This is very, scary to give the control to the AI, but the research again showed promising results in this sphere too. So we might try it. Okay, so now we go to the data analysis. First of all, what is interesting here is that we tried, so we had all of these features that you see on the x-axis are presented for the two apparatuses that we have. So in our data sets, there are two diffusion apparatuses, and all of them that have those features. And out of these features, we predict this load feature in the next hour. What we noticed is that load is correlated, right? So we have 70,000 rows, and somehow the load has a correlation of near 0.4, and it is significant because of the number of rows, right, that we have. But also we noticed that temperature of some of the cameras in the apparatus is really highly correlated. It's like near 1. We think that they're connected somehow, but the explanation we got from Yeti is that at least for the load parameter, is that they both are loaded with the same type of stuff. Okay, and also correlation depend for the features overall. We also see again that apparatus to apparatus function correlated, but again, there is also this blob, so the features are also correlated in between them. So we might explore this in the future. Okay, so we also did this, and this graphic shows, basically we took each feature and we tried to understand whether this feature on the average will be different for instances where in the next hour it will overload or instances where it won't overload. And we noticed no difference for any features except this one, which is the temperature in camera one. And somehow it is a bit lower, but we would have to calculate p-values and stuff to verify this in the future. Okay, so we actually trained a very simple model. We first of all, we added features to our data set. We totaled around 500 features in the result as a result. And so what we did was, like, things people use in dimensional modeling usually, we just added rolling means, rolling variances. As a result, we see that only rolling means are the most important here when we do the sharp analysis. So the results were pretty interesting because, as we see on the precision, recall, and accuracy metrics, is that first of all, our data set turned out to be pretty balanced, right? So we predicted if in the next hour the apparatus were overall, this made the data set really balanced, and we got a score of 80% accuracy in total, with that we detect 88% of overloads, and that when we detect an overload, it is our prediction is correct in 72% of cases, and we did this with simple linear regression, which is interesting because we got those good results. Maybe we have some data leaking going on. I don't know. We'll see about that, right? But we checked. It seems that not. So what we plan to do in the future, this model obviously is really simple, and maybe this kind of metrics are not enough for effective. We still don't have recommendations, right? We still cannot say to the operators what to do to prevent, right? We say that, well, there's some probability that the apparatus will overload, but I'm not sure that this will work with people, right? So they will see this probability and they will know what to do, right? We did sharp analysis on the input features, and we got the following results. The top features are usually water temperature, right? Which seems logical. Yeah. So what we will do in the future is actually look into how we can interact with the operators, how their actions influence the features that we get, influence the overloads, and maybe possibly, because this is very far-fetched, but if we are very good on predicting action and effect, maybe we can explore reinforcement learning approaches. But of course, this is not what was required from us. Thank you for your attention.
Yeah, and we don't have microphone, not working.
I have a question. Have you included such feature as viscosity or density of this mixture of water and beetroot?
We included those features that were presented in the data set. I'm not sure that the features that you said.
Because it from the point of physical and colloidal chemistry, it may have an impact.
Yeah, of course. This is very true. You're
and
correct.
The viscosity may also depend on the variety of beetroot.
Yeah.
That may be loaded.
Yeah, you're absolutely right. This is why we see a correlation in the load, right? So when we load different substances into the diffusion apparatuses, there is, because there are two of them, right? We load the same stuff into both of them. We see a correlation in the possible, in the load, right? In the amperes that they consume. But in the features that were given to us, at least, there is no such thing as viscosity. And I believe that it will be kind of hard to measure this, right? I'm not sure, right? Maybe we can measure this, but I don't know. We were not given this. I don't see it here, right? We were given like technical characteristics of the apparatus. Yeah.
Okay, thank you. Another question.
I want to ask, why is it necessary to essentially use embossed programming? I think that system that you monitor, like the viscosity levels or the temperature of the silo, I guess, that controls the output. Why don't you use like just You have a nominal, like a nominal level of temperature and your actual local readings, and just use like this disturbance and linear control, for example.
Okay, so
we find like some alternatives to reinforcement learning.
yeah, of course. So reinforcement learning is a very far-fetched idea because to train reinforcement learning, we need to model the whole environment, right? Because we cannot just like put a training model in charge of a like existing apparatus and let it train, right? So this is very, very far-fetched. So reinforcement learning is something that we think about, but we're not actually like it's not actually our aim. Our aim is to work with operators and to give recognition to the operators. And as to your second question, I don't think I understood what you meant. Can you like help me understand?
So we just can't use like gradient of our controls. So the levels used for the temperature and how the like set level that we want to go for our temperature or like some parameters.
Okay. So you're asking if we can come up with some criteria for the operators that they can follow, so that like we ask them, please make the temperature fall in this range, and then there will be no overloads, right? Yes, of course, this is a great idea, but we tested whether features by themselves predict an overload in the next hour. And it turned out that, well, we didn't find such features. Every mean was the same for the no overloads or overloads. So we cannot just do it like this. So we need a model. Yeah.
And you can use, if you have a very physical model, you can use model with control.
Yeah. I guess. We'll see.
It's like too far shared.
Yeah. It is very far.
Predictive control, everything. So just try something that work.
Yeah, of course. Yes.
Okay, thank you.
Thank you.
Also, I saw only 6 teams wrote in WhatsApp that they presenting. So if you want to, if you feeling like presenting, then please add your title so we know, because in total we have 16 or 17 teams, so we need to know how many will be presenting to calculate time. Okay. And please come to Zoom before you go, not after. Okay. Connect to Zoom now, not after you go on the stage, because we lose time. Join Zoom, come on.
Okay, hi everyone, I'm Dima, and I'm presenting the project, the team that works on the project for sugar beets reprognosis. We're going to be forecasting some sugar. This is a project by the Buch company. Our team consists of 4 people, me, Alana, Juliana, and Sofia, and our mentors are Mikhailo and Mikhailo. So the problem statement is that sugar yields in sugar beets strongly depend on various characteristics, on like weather conditions, on crop management. Like it is a very labor-intensive process, and you have to spend a lot of time like managing, like measuring stuff. This process is very dependent on timing. So like you have to carefully time when you want to collect the beets, when you want to start the plants, like producing actual sugar, and or else you will miss out on a lot of money. So basically the problem is we need a forecasting model that predicts sugar content dynamics based on various characteristics, including weather, solar radiation, geospatial data, data from agronomics collected on the spot, and stuff like that. So our solution is we The first one, we're going to get known with the domain because we're not really familiar with it, but our mentors provided us with some materials, like a big book about how to grow sugar beets. They provided us with different data that we are going to study. So first of all, we are going to prepare weather and agricultural data from on-site stations, weather stations, from the people who are on the spot, and satellite images. We're going to train different models for the task. We want to try out classical approaches like ARIMA models, some new time GPT model from that was presented earlier on this school, and we want to predict to use also ML approaches to train some models. Then we will evaluate the performance, so features that largely correlate with sugar beet growth, and develop and validate the models. This is a pretty straightforward approach, but yeah, more details gonna be soon. And then we are going to forecast sugar beet growth and work with the team at Zachit Buch to integrate our solution into their system, or hand off the data, yeah, whatever. So that's it. This was a quick one. Thank you for your attention. I'm ready for it.
Thank you. I have a question or maybe a remark. Is it a lot of things you can change when you grow this type of vegetable? So, I mean, you put seed into soil, and just if it's a lot of sun and a lot of water, it will become great. So what you can actually control here?
Yeah, so first of all, you can choose the soil that you put the beets in. It depends on the previous cultures that are growing there. Mentors told us that they grow the beets once per every 3 years. They rotate the crops and then yeah, you can control how much. The weather. You can't control the weather, but you can control the degree days. I think that's how they call it. How much forms of sun the gets accumulated basically.
How we control this?
You can just time a specialized person goes to the fields and they control they measure the beats.
You measure, you not control.
Yeah, measure. Yeah.
You can change it. Okay. So and how for how many years do you have data?
I think there is some data from the 90s, some other data. It kind of has chunks missing, but I guess we will have to use the satellite data from NASA. They can provide us with the radiation with the amount of sun radiation that was radiated in that region, and yeah.
I mean that if there's a 3-year cycle, then you basically 3 years is just one chunk of data, meaning for influence that influence the problem.
Mm-hmm.
Yeah, so you need at least few of this. Okay. Any other question or remarks?
Okay.
Okay, thank you.
Thank you.
Hi everyone. We are presenting our project, the Ukrainian Habitat Mapping Research. Let me introduce our team. I am Olena Litowska, Bachelor of Science at LPNU. Юліан Мишко, PhD student at KPI, Eugene Vinukur, Bachelor of Science at Naukma, and Oleg Samolenko, PhD student at NAS of Ukraine. Our mentor is Oleg Prilutsky, and we want to have a special thanks to Joseph Achman and Yaroslav Pritula, who guided our brainstorm and gave us actually a lot of useful advices. So,
our problem. So, what is the extent of the damage done to our ecosystem, our natural world? You know, our environment has been going through a lot for a recent decade. The global warming, the toxic waste accumulation, the Russians burning it to the ground. There are numerous estimates, but there is a definite answer to that question, which is no one knows. Why is that so? Because in Ukraine, actually, we don't have a natural habitat map. Like, it does not exist at all. Such a map is essential for post-war ecosystem restoration, biodiversity loss monitoring, integration into the EU frameworks. Like, this is really crucial in our current time, and decision-making in forestry, agriculture, and land management. The key challenges to build such a project, such a map, is that there is a huge lack of data. Data is not available, not open, and is very scarce. Like, we have 16 data points in Novokhovka, and we are expected to build a ML model to cover all Ukraine. Impossible task. Also, the data comes from very heterogeneous sources, meaning that we have audio data, photo data, news data, etc. Interpolation, extrapolation is very hard to do with such a limited data. Also, data changes very fast, also due to the war. Like, today, this is the forest, tomorrow, this might be a crater. We have solutions like a random forest. It works to some extent, but it's too inaccurate, inflexible, and local for national scale habitat mapping.
okay. So the aim of the project, having the map of the land and some information about the local areas, which actually describes huge different classes of the different habitats, which also have a lot of subclasses of habitats. Some of them we have hundreds of subclasses described in different biological habitats of our land. And we want to having that information to distinguish those classes and even the subclasses of this land. And the same way, just to help the biologists and the scientists discover more, gain knowledge of our land, country, and gain some insights.
Yeah, and now going to our proposal. Considering the fact that we don't have much ground truth data, we decided to use the Google Satellite Embedding service, which is trained on high-dimensional satellite data to provide an embedding which represents, which specially represents the provided location. Yeah, and maybe next slide. Yeah, usually habitat is not a point, but an area. So we decided to aggregate our points into polygons to represent the habitat as an area. And we, of course, we get a high-dimensional embedding, which is also called a super embedding, which is high-dimensional and hard to process. So we applied the dimensionality reduction here. As a polygon, we use hexes, which is obviously not on our insight, but a common and effective way to represent the Earth's landscape. And it also opens has some openings for us for further improvements. This such a polygon. Yeah, and then we go to the clustering step, where every point is super embedded I was talking about the previous slide. And we try to cluster it using your favorite clustering method. And an important note here that we choose the number of clusters. It should not be exactly the amount of classes in needed classification. We can use more to obtain some more important understanding of clusters and habitat types, which Evgen will talk about.
Yeah, so we talk about unsupervised clustering, and it might reveal new insights for biologists on ecosystems belonging to the same kind. So essentially, they could fall into the same cluster, while they could be different, like a mountain in Romania or something like in Switzerland. They could belong to the same like biotype. On the flip side, if we know in advance that this ecosystem is like a jungle or a grassland, pixels for different biomes should fall into separate clusters. And that's our validation that our method makes sense and can separate clusters immediately. We also can like discover insights where like they're related if they're close together, some biomes. Additionally, experts can discover at first unseen, abandoned ecosystems, but how and how the zones near the function. Yeah. Thank you for the attention.
Yeah, and also we have truth data to compare our cluster predictions. Yeah, thank you all for attention, and you can contact us or subscribe to our project using the following QR code. If you have any questions, follow us.
Okay, that's ambitious project, I think.
Maybe done.
Habitation of all Ukrainian. Any questions? Mark?
Which region are you going to start working on?
Yeah, we will start with regions where we have the most data,
like European regions.
Like European regions to test and validate our results. Then we can proceed with Ivano-Frankivsk and Odessa regions because we have land cover data by EU done for these two regions. Then we can do the rest of Ukraine and the frontline territories.
Yeah.
Yusuf?
I just thought for the clustering, there are these new types of hierarchical clustering methods that I think would perfectly fit because you can cluster in the big clusters and then you go dig deeper and each cluster you can actually sub-cluster into more clusters. So just to consider.
Yeah, thank you.
Yes, thank you. Good. So good luck.
Thank you.
Work on project. We will see the result in October. Okay, next. Potentially we can then provide it from our ministry because there's a data that's actually very needed. We don't have information about how many people live in what area and how and why, and it's actually very important statistically. Yeah. Okay. What's exactly?
So hello everyone. We are pleased to present you our project about recognition of crop condition using UAV photos. Our team consists of me, Tetiana Vasko, Alena Nazarenko, Evgeny Kolomiets, and Alexey Izmakov. The input data of our project is a set of 700 drone photos of agricultural fields. And the output data is a map with highlighting problem zones that can be used by different farmers to monitoring the process.
After analyzing this data, we categorized all the photos according to the type of filed condition. Some files have tracked that by agricultural machine. Also, there was an area where plants were not able to grow enough. We also identified cases of crop flooding as well as dry zones affected by the drought. And finally, there are normal files without visible problems, which we used as a reference for comparison.
Okay, so we try to work with our data because there are two kinds of files. There are PNG, portable network graphics, and JPEG. So we convert one to another, and after that we try to normalize because by second parameter, because there are two kind of resolution. So one part of data of photos have like 4,000 and 3,000 pixels, and another class was like 2,000 by 1,500 pixels. And the next feature, there are two kinds of photo by altitude, because we at this point of time we don't have data about altitude of drone, but we think this is a meaningful feature for this task, because in some kinds of photo we have like sky, and this part is maybe not is meaningful for our task. And after that data preparation, we try to find a way. At first stage, we use like SAM method. It's like segmentation anything model by meta AI. And we can try to represent you one of some examples. So we find distinctive like lines between some parts of photos. So there are fields, and there are tracks, and there are woods and sky, and so on. And the next step, we will try to use like pre-trained model. It's a visual graphic model from Oxford University, and this is like convolutional neural networks, VGG19, with 16 layers, and 16 layers, and there are like 144 millions parameter or features. And this have like embedders. So we create some embeddings from that model, and after that we use cosine distance, because this is better idea. Of course, we said thanks for Yaroslav Pretula and Joseph Achman for ideas and some brainstorms yesterday. And after that, we use hierarchical clustering for find some groups. And so we can see one of these parts of photo. Our next steps, so we find some projects on GitHub and in scientific sites like Science Direct and in other place. And so we can try it after we clarified data and have another part of data. We can try to use this algorithm for like next steps and better results.
Maybe a question for the problem, and one of that idea. We have one of that problem with data, but we have option and algorithm and little mathematical model in use it right now.
Okay, thank you for your attention. Okay, any questions, Mark?
Can I ask, where in that book have the same project, the same idea, same problem? Can we This one hope cooperate for two projects to databases.
Yeah, I think we can be.
I think we can discuss it after the project, after the presentation.
Okay.
Yeah, just find them, or maybe I can provide you a mail. Why not? Okay, thank you. It's a good idea to work with. And do we have another? As I saw, we have nine requests for presentations, or even 10. Yeah. 9. Okay. And now it's 7. So we have only 3 left.
One second.
I just remind you that you worked with beetroot, not horseradish.
Hello.
Can you make it full screen? Present the voice.
Don't forget the microphone.
No.
No, it doesn't work.
Probably didn't click.
You present the whole screen instead of the video.
It's already on the full screen.
So
on the laptop.
maybe she
Yeah.
just make share, not that wrong window. Share full screen.
You have to reshare.
In the browser.
Oh.
Yeah, because it's she won't put dates on this.
There.
We will try to develop a middle video prediction model. It's extremely important for our providing master data for stock. So it's important for agribusiness in order to analyze whether data and perform proper treatment and timely fertilizing. It's important for logistics in order to allocate resources properly, and of course for trading to plan their origination strategy. Our model, our baseline model will be based on weather and satellite NDVI index, and also on our contributor provided us with their incorporated data with time series of fieldworks and treatment. Our task is to develop a base model that will predict yield on particular field, and to develop confidence intervals to perform to obtain base the worst and the best scenarios. So yes. So
weather data is very robust. We have to analyze to choose the time period properly in order to find the periods that the most impactful for certain stages. So we will try to build an ensemble model that will be run every week from the 22nd week of the year. It's usually end of May. So we can analyze each growth stage, and our client can perform proper decisions to improve the conditions. So we will try to make an ensemble model that will include different features at different stages, and will be rerun on weekly basis. So our model will be used for better planning decisions. That's all. Do you have questions? Thank you.
Next presentation. Give me a second. All good? Yep. I'm going on Zoom.
You took my request to join Zoom before your presentation.
You must say slowly. Let me share my screen.
Hi, our project is about sugar beets and we'll be working. Yes. Hi, our project is sugar beets and we'll be working with Zakidny book to complete. This is our team. We are all first year bachelor students here at KU. This is Alana. She's an ML engineer. This is me. I'm also an ML engineer. And this is Katerina. She's also an ML engineer, but with a happy face. Our mission is to save poor beets from death. And I'll explain you why this happens in an example. This is beet. He's growing and he's small. If we harvest him now, we won't get much sugar from him. We won't get much sugar. Like it has a lot of sugar factories. And without sugar, they'll go bankrupt. This is an unwanted outcome. So we need to wait for him to grow. Problem is, we do not know how much we need to wait and for how long. And for this, we need to predict late. Because if we wait too long, he'll start to rot. And if he starts to rot, he'll die. And he won't be happy. This is also an undesirable outcome. So to solve this problem, we have a lot of data. First data we have is yields of the beets. We have this data in detail from 2016. It includes date of the yield, the type of field that was used, the predecessors that grew in this field, and the field area, etc. Also, it has the data about fertilizers that were used and how much of them was used. Also, we have comments from Agriman. This is a guy who comes to the field and checks experimentally how much sugar there is in the beets. The sugar percentage in the beet is a crucial metric. It determines the maturity of the beet. If the sugar content comes to a certain threshold, it will start to rot and it will die, which is an undesirable outcome. Also, we have weather data from Zahidni's books, Meteo Stations, which is quite important as the weather data from general weather data will not be as detailed in the fields that they have as they are in the middle of nowhere. The most important metric here is sun radiation, as the amount of sugar in the beets is almost directly linked to the amount of sun radiation it consumes. And we'll be looking at this metric in detail. And the last but not least part of the data that we have is the Sugar Beets book. It's about a 500-page book, which we'll be reading meticulously in the next few days. And it contains everything you need to know about sugar beets. And overall, we plan to first develop a base model using basic ML methods, using our yields data, and then go step by step, adding features like weather, like comments from agreement, which may be difficult as they are probably in plain text and we'll need to parse them in detail, etc. Overall, we will plan to use these small steps to develop a highly accurate model and safe beats. Stay tuned for our results. And if you have any questions, we'd like to answer them. And also we'd like to thank Yaroslav Petula and Alexander Kolosok just because we like them.
Was great. Okay. Great. How long did you do this presentation?
Half an hour.
Wow.
Maybe a bit more. Not long.
Yeah. Why do you sit?
I'm told that there is a song called Question, but I'm not privy to the details.
So she doesn't have any connection to Beetroot.
These are last tune out.
A lot of eggs hidden here. Easter eggs. Okay, thank you.
But it's not eggs, it would be crab.
Caviar.
It's not caviar.
Yeah.
How exactly are you going to use the book about beetroots? Because I see at least two problems here. For example, the book says, let's say, no fact about roots with beetroots, and your data is against this fact, for example. What will you do? And the second problem is, for example, book says something about some metrics about beetroots, which you don't have in your dataset. Once again, what will you do?
I think that this is not a problem that will. These may be problems we encounter. But the problem is that we are not subject matter experts, so and we'll mainly use the book that will become once. And we have some side quests that we would like to complete. And this book is quite large and it contains a lot of information. And as I said, we will meticulously read it. So maybe we will develop a RAG system for this book so that we can get information from it more quickly, more efficiently, and in a better format for us. Overall, I think that there may be conflicts, like you said, book might say one thing, data says other things, but I generally think that we will not be using the book as data for the model. We'll be using the book as understanding for us, and we'll trust the data that we have from Zahid's book.
Okay, thank you. Thank you again. Good luck. Because you said there are a lot of projects about Beetroot and well, the one is best presentation probably will win. Okay, next we have
Hello everybody, and we are going to present you a project titled Forecasting the operating conditions of the vision system, which will be developed in collaboration with a startup. And okay. So we are a team of 3 people, and this is Victoria, Daria, and I'm Marta, and there is a lot of missing, unfortunately. And we have all quite diverse backgrounds. So let's quickly talk about the data we'll be using. So we have data collected from 2 diffusion apparatuses, and you can see a schematic representation here. And we have 15 continuous variables collected for each apparatus, and overall we have approximately 7K measurements recorded, which cover a full cycle of a full working cycle of the system. And yeah, so our problem is the following. As a previous team working with the same project said that there are human operators which work with diffusion apparatuses, and there are 2 modes, manual and automatic. So each minute we receive like the figures from that apparatuses. And the problem is that the team is lacking this early warning and recommendation system, which would help them avoid loading risk. And our solution is the following. So it consists of 2 paths. The one is for transformers, and the second one is for ML forecasting from Mixcloud. So first we have to process our data, and we have several values missing. So they are not missed. Some are not missed at random, but some somehow are missed. So we would like to replace them with using the proxy variables, which means that we have to find the correlation between features, and those which would be highly correlated can be replaced with, if missed, can be replaced with its proxy variable. Then to avoid multicollinearity, we would remove most of the proxy variables and move on to next step. Like if we work with ML forecasting, we would just immediately use this method after imputation. But if with transformers, then we would move to regression to see the weights of each feature, because in ML forecasting it is done automatically. And we will also like to add to do feature engineering by adding variables which would summarize our change in feature in an hour, not in a minute, as it is given in our dataset. Because as the company said, we have really high inertia, so there is a big window of time between our action on the apparatus and its result. So that's why we want to summarize our features hourly.
Also, we search for another related works, and one of them is machine learning-based warning system for clinical deterioration. Why so? Warning signs frequently appear a few hours to a few days before the loss prediction window, incorporate trends in risk scores, adjust for varying numbers of clinical cohorts, continuous measurements, continuous or intermittent vital sign monitoring through wearable devices and besides monitors, prediction of deterioration risk to be a classification task, and retrospective in nature, leaving open to the possibility that algorithm performance in a clinical environment may be lower than the performance achieved in a controlled retrospective setting.
Okay, so in this preliminary work we did, so we made some hypotheses, and for example, we still need to check carefully whether we can apply practically the methods that can be found in this paper that Daria just presented to you. And also we were somehow thinking of distinguishing regular behaviors that in our case are overloads from chaotic ones, maybe using some methods from dynamic systems theory or nonlinear time series analysis. And also another interesting thing is that we have some missing values, but for example, since our data covers a full working cycle, in the initial and final part, we may have some missing because of the functioning of the system, which means that at the beginning, some parts of the system are still not operative. So we have missing values, but those, are key to the functioning of the system. So here you can find some references, and thank you for the attention.
Okay. Questions? Which company?
Okay, it's good. It's not exactly machine learning as I see it. Yeah, you want to use different methods, but it's fine. The main thing is to get the result. Good luck. No one here, then just take the stage.
Yeah, I'm in the queue, so.
Yeah, but they were also not with you. I understood. Did you put information in WhatsApp to look for them?
Yes. Yes, and I added after that, so yeah. Well, yes, so my name is Irena Zayets, and I totally understand that this topic is, sorry, wrong move. So, yes, so my topic is a bit off top, and the only connection I have with Beetroot is that I work as a Python teacher at Beetroot Academy.
Right.
Oh, see. I think, yeah, it works. Yeah. So actually, I will work under the supervision of Vladimir Vahidov, and this topic is more connected to the behavioral economics, not with agrodata. So yeah, so sorry for that. But actually, what I want to do in this project is to analyze data and to make some sort of funny things with some statistics and analyzing all of the data. So speaking about the project background, Hunter had conducted some kind of survey and he collected more than 600 responders, yeah, and he tried to test if people fail to follow the simple instructions or they do follow some complex tasks. So that was like the mission of the surveys, and he had an interesting result from this test, you know. So speaking about this test, so this is the CRT, so this is the cognitive reflection test, and what we already know about this test, so it was made like almost 20 years ago, yeah. So it actually the purpose of the C test is to show the process of like how the human thinks and how they think in terms of their like two systems, you know. So it's not I think it's not pretty new information for you that our brain has like two systems, you know. So the first one is slow and the second one is fast, you know. So this test which my mentor used to conduct surveys, so he tried to measure how can people like work with those two systems. And he collected pretty interesting results. And that's what we found, you know. So most psychological biases worked as expected. So it's what's not pretty for us. And people showed like classic cognitive patterns. So as we all followed them. But we've got some interesting results because, for example, one psychological bias as anchoring doesn't work, didn't work at all for us. And also, there was a pretty weird situation where the simple control task, like please make an ID from 3 different words and 4 different figures, it totally failed. So that's the mission of this project, is try to understand why people do some failure in like following the simple instructions, and why people do not fail some complex instructions, you know. So why do we think in such way? So we try not to dig into some deep psychology or sociology. So it's more about like analyzing the data and trying to understand like what's going on. So speaking about the pre-research that was done, so there was an analysis of correct answers, but they didn't explain to us why people would just fail simple instructions, you know, like what's the deal? Why people can't just do straightforward and do some really simple steps? So what's the problem? So my approach is to do from the opposite. So I want to analyze not the correct answers because I think that it will not give me some valid data and some valid understanding, like why people do not follow simple instructions. So I want to analyze for incorrect responses, and I want to start from making some classifications, maybe some taxonomy and so on. And also I want to make statistical analysis. So as
as a graduate from the applied mathematics faculty, so I really like to do some statistical analysis and so on. So yeah, so I really like this idea, and so my plan is to analyze the incorrect responses and why people do like some wrong steps. So yeah, so the goal of this project is to discover some behavioral patterns, not deep psychology, sociology, and understand this how and why instructions fail. So understand these failures. Yeah, so why it didn't work at all. And the tools I will use is R, Stata, Python. So it depends how much time it will take. But I want to also do some maybe modeling using ML, but it's a matter of time. So yeah, so speaking about the expected outcomes. So as I said, I want to make some classification of errors. I want to find these failure patterns, so why people failed these instructions. And also I want, if I could do it, I want to make some improvements in the server design. And also, if I do all these steps successfully, so I think it will be a good material for some humorous article about, about some human priorities and how human fails simple instructions. So, so yeah, so that's pretty all from my side. Thank you for your attention, and maybe you have some questions.
Thank you. Yeah, I have another question. No, don't. Because
yeah, there will be
for. Okay, any questions, comments? Yeah, it's.
That's an interesting statistics challenge. And what kind of data do you have? How many features? What are the features and the target variable?
Well, speaking about the data that I have, so I have depersonalized surveys. So there is no like personal details about the people who took part in those surveys. So I have like the answers for all the questions. And also I have this CRT test with all of these questions. So, so yeah, so I will start from, so it's not, it's just like 600 records with like some kind of 20 questions. So it's not the huge database, but I have this data, so I will try to start from the most complex task. It's just like the following the simple instructions, but which task has the most failures, like the bigger number. So yes, I will start from it.
So it's like a pre-filled form filled after the exam survey, not the exam itself with the questions.
No, it's like this exam. It's not like for so it's I have this form that they filled out, and I have the answers. So the answer is collected into some kind of CSV, not the CSV, sorry, like Excel table. And it's like a huge Excel table. So I will try to use Python for reading the data from it and some kind of preliminary statistics and so on. Thank you.
Thank you for your presentation. I want to ask about not the dataset features, but your data features that you're going to extract. So as I understood, you have like text question.
Yes.
And what features are you going? Is it like NLP task? How do you think you are going to extract features to identify like patterns why people answer those questions wrong, whatever their rephrase, whatever the like sequence of the options of the answers? How do you see this task?
Thank you. This is a really interesting question. So, so as we discussed, we decided not to dwell into these psychological biases
the connection between them. So we want to start from just simple, like find the question with the highest level of failures and try to analyze these failures. So because previously people tried to analyze the right answers and it didn't work at all. So I will start from, maybe it's called extreme. So the answer with the highest amount of incorrect answers and with correct answers. So I will start from this extreme and then we'll try to see any connection in those, because if the task for a person is to create an ID with ABC 1, 2, 3 and some person put my name is Vasil 2022, so like by this person did that. And also, yeah, speaking about the NLP, I would love to do that because, yeah, I really like this language processing stuff, but I'm not sure if we have enough time for that. But yeah, so the primary purpose for this is to write some humorous article with some statistics and so on. So I'm not sure how deeply we will dig up into that.
Yeah, just to add 50 cents, Lena made an interesting point. Just as an idea for you to try, you can do text embeddings on the questions itself and to check whether those correlate or relate to the target variable, wrong or correct answer. And as in our project, you can do dimensionality reduction and to see if there are clear clusters like correct, wrong, and probably you will have some outliers. That will be your intuition that there's definitely something in the question itself that.
Yeah, there is definitely something in the question because each question contains some psychological bias.
Yeah.
So yeah, so sorry.
You will be able to quantify it.
Yeah, I totally understand that. It depends, how much time we have in hand. We want to dig into that.
Yeah. All right. I just want to add that I could share a paper on uncertainty, so it also like tests the difficulty of test for multi-choice questions for like NetLab exams. They used the LM to basically score the like difficulty, and it also measures like it delves more into the uncertainty and like what types of errors are still like related to some like causes. Basically, like what types of uncertainty like we to probably.
But here it's not about the uncertainty; it's about like psychological biases. So it's not. So we have different types of biases, and not each bias contain these uncertainty. So for example, we have four questions, and each question has some influence to another. So it's like the chain, So
so the order of question, like the answers matters, or just
yeah, yeah. So the order of questions also matters. So yeah. So there is no one like approach for analyzing and for connecting into one chain all of those questions because they differ and they have different psychological bias. So for example, anchoring. So for example, RCT and so on. So yeah, so it's like different parts, not the whole one.
So changing the.
Don't make me different. You can do it afterwards. It's not a question. It's just I want to give you one paper, and yeah, yes, thank you. Yeah, nice. On this high note, we conclude our presentations. Thank you. Now our plan is we have a break. You can go and check out from your hotel because you need to check out at 12. Yeah, So if you are in a hotel, you need to check out till 12. Otherwise, they will start another day. Yeah. And and at 12:30 we will meet together for closing ceremony. I will give you certificates. There will be photographer to make photos, and we will end. Yeah, same.